Okay, so last time in the last half of the of the video recording, I talked through the dividend discount model, which is by far still the most prominent, most popular model in the market. And why is that? And it's such a simple model. If you look at it, it's so simple. It's like simpler beyond one line. It's like half a line or something. But the thing is, if you look at all those numbers and all the datas that's posted in the market every day, the prices, the returns, the news, the discussions, the trends, the momentum, all those things, it is a lot of noise. It is a lot of noise. Okay, so if you put that kind of noisy data, you want to extract something from it and put it in a very delicate, precise, accurate model. What do you think? It's not going to work. It's not going to work that way. As people in the field often say, is that garbage in, garbage out. I mean, if you have very noisy data in there and you want to put it into something that make a meaningful attempt to actually do something with it, it has to be a high level of simplification. So if you go in the future, go into the field, and everybody will tell you, oh yeah, this we use this high-end model, that high-end model. They have the finance, the whole finance theory has advanced for many years and advanced drastically over the discounted dividend model. However, it always helps to have a backup simple model that you can make sense of, okay, to compare and to serve as a benchmark. And this is exactly what this one is doing here, the discounted dividend model. So simple, very intuitive, because essentially the price of all the securities are supposed to be the present value, sum of the present value of all future cash flows. So very, very nice idea, and then discounted over a very simplistic one shot for all required rate of return. So is it accurate? No. Does it have flaws? Lots of flaws, lots of things. For one thing, does it make sense for you to discount something, discount all these cash flows with one return? Well, of course not, right? The short-term debt, long-term debt, they all have different rates. If you go to the bank, ask for 1 month CD, it's one rate. 5-year CD is another rate. If the different time frame, different term of money should be discounted, should have a different interest rate, why do you expect to discount everything at one rate for all these dividends, especially when the stock dividends are going to stay there forever? So yeah, it doesn't really make sense, like 100% sense, but intuitively it really helps for people to be able to understand, hey, this is the dividend discount model, and dividend is going to grow at certain rate. Yeah, is it going to grow like every year at that rate? Of course not. Nobody is expecting the exact number to happen because nobody expecting themselves to foresee the future. However, on average, you can think about those average growth rate would happen or be a relatively good forecast. Another aspect of looking at this is that now that you know this model, you can understand, you can try to interpret the market price trend or the market price difference using this model. So for example, if the market price of Apple company stock all of a sudden increases this and this much, now what do you think? Is it because the discount rate goes lower? Or is it because the growth rate goes higher? But that is the way you can interpret and kind of go back up certain kind of market information. And of course, up to your opinion, but you can fit all sorts of bits of information into this model and see how you think. So again, if we look at the whole thing, basically we're talking about a discounted dividend model where the price, P0, is equal to D1, the next period dividend, divided by required rate of return, RS, minus the growth rate. Okay, now the next period dividend can be calculated as the last dividend multiplied by 1 plus G. Okay. And if we compare this one to this one, they're the same. Yeah, they're the same. What's the story? Okay, so this particular slide, as a reminder, was at the end of the last video. It's about multiple different growth rates. So suppose there's a company that's not going to grow at a constant rate, but growing at, say, a very high rate in the recent years, and then all of a sudden go down to a constant long-term rate, which is kind of a reasonable setting, right? So some companies, they're able to grow very fast at the very beginning, but eventually going towards the cash cow kind of model. Remember, you learned the 4 or 5 different business phases, probably in marketing or some other business classes. Or if you haven't learned it, you'll probably learn it in the near future. So basically talking about a company will go through several different phases at first, and they start up, high risk, high rate of failure, and then also high growth. And then you go into a steady growth, and then you go into a stagnant phase, which is oftentimes people think about it as cash cow, and which is kind of very low growth but continuous, but then eventually the industry dies out and the whole company will be like slowly die out. So we're talking about a third phase in the later stage. So we're talking about maybe from the first year, second year, third year is having certain amount of growth, and the last year, and the last from the third year on, it will be the GL that dominates the low growth rate that dominates the rest of the process. So if that is the case, then if we look at the whole thing at this point, let me draw an eyeball here. Is it okay? Okay. Better? Okay. So we look at this and we try to evaluate the whole stock at that point. If we try to do that, then we are going to use this one, where the dividend T is the dividend at this time point right here. Okay. Then growth rate GL is the long run growth rate, and the required rate of return is RS. So you're going to do exactly that. Okay. So what are you going to do in that case? Well, you are going to take you're gonna calculate these dividends individually from the previous dividend multiplied by 1 plus that year's growth rate specifically. Okay, and then after you calculate all those, you put on this time point, what we call the horizon value, which is the value you got from here, the horizon value. Okay, so that's the plan. No, sorry. Okay, in this particular case, in the first year, growth rate will be 30%, second year, 25%, third year, 15%. As you can see, in the first several years, the growth rate kind of volatiles a lot. Then in the long run, the growth rate will be 6%. Now, you put in G1, okay, you grow the D0, which is $2. At G1, 30%, you get 2.6. Then you grow 2.6 at G2, 25%, you get 3.25. Again, you grow 3.25 at a growth rate 15%, you get 3.7375. And then you calculate the terminal or the horizon value, not the terminal value, the horizon value. Okay, so using D3, which is 3.7375, multiplied by 1 plus the long run growth rate, divided by the difference between the required rate of return and the long run growth rate. Okay, so that will give you a 56.596. You add the 56.596 to this part and discount it the same way as this part, the last dividend. And then you add it all up. Okay, so last time, this is where we stopped. And I want to show you, remember we talked about how to calculate it using a cash flow. Using the cash flow side of this. So let me think about how to do that. Okay, so maybe it helps to do this whole thing like this. Can you see? That way. Okay, so now if we have the financial calculator, we don't have to do all the individual discounting here. All you need to do is using the cash flow. Okay, so, oh shoot, this is the opposite. Let me see. Well, I'm sorry, you'll have to flip it like left and right, because what you see is probably the mirror image of this. Anyway, you find the cash flow here. Once you press the cash flow, you can press the second clear work to take away everything that's left in the memory. Okay. And once you do that, you have a clean slate, and we'll get it worse. And it asks you for the CF0. Okay, so CF0 is what we call later on the initial outlay. It assumes the model that you're going to pay something today and get something later. So in here, we don't have to use the CF0, so we keep it as 0. In the next period, the year 1 cash flow is going to be 2.6. So we put in 2.6 and press enter. And go down, we see that F01. Okay, so that F01 is the F01 tells you how many periods that CF0 will go. So you keep it at 1 because 2.6 is only going to repeat for once. And then we have 3.25. Enter, go down, keep it as 1 repeat. And then in the last period, we have 3.7375 plus the 56.596. equal to, enter, and again, only for once. So once we finish that part, all we want to do is the MPV, present value. It will ask you for the interest rate. And the interest rate here is the required rate of return, 13%. And you are going to compute, and then you're going down, and then press compute, I think. That'll give you, why is it this number different? Yeah, MPV, what is this one? And FV, okay. So the MPV is 46.67661. And it's slightly different from that because from the slides, because of that is because of the rounding error. Okay, so I hope you can see it. Now I will start wondering, do you see this part or do you not see it? Well, anyway, next time we can get that part done in the class. Okay.